Hello,
Yes, sir.
can you hear me?
Yes, sir.
Okay. Uh, so in the last class, we looked at functions and also
And
limits basic idea. So limits we saw, if you say limit x tends to a, f of x is equal to some L, then that means that as you approach x is equal to a, the value of the function tends to some value, which is L,
yeah,
right? This is the graph of the function as you approach x is equal to a from the left side or from the right side. Both the times the function value tends to the same value, L. So if the tendency is same from both sides, we say that the limit exists, right?
yeah,
So we saw some examples of y is equal to x square. If you say limit of x tends to 2 x square in this function, the limit will be 4
oh,
because on the graph of the function from both sides, you are approaching the same 4 value. As you come closer and closer to 2, right?
yeah,
Where whether you come from 1.9 side, lower side, or whether you come from higher side, the function value will tend towards the value of 4, right?
yes, sir.
So that is the meaning of limit. And using this concept of limit only, we will define what a derivative is. Okay. So
Oh,
if you see standard books like NCERT, if you see 11th grade NCERT maths, right, for example. So in that, there will be a chapter on limits where they will ask you to learn how to calculate limits in different situations. Okay. So
yeah,
that is not super important right now for us, but you can look at it in order to understand how to calculate limits. It is fairly easy. If you see the chapter, you will understand. But we'll not spend too much time on limits. We'll look at what a derivative is. Okay. So
okay,
derivative, basically, we will use the limit idea to find the derivative. But before we do a derivative, you need to know what is the meaning of slope. For example, if there is a line like this, line equation, is right, y is equal to mx plus c and all, right?
yeah,
So this is the y-axis, this is the x-axis. If there are 2 points on the line, the slope of the line, let's say this point is x1 comma y1 and this point is x2 comma y2, right?
yeah,
The slope of the line joining x1 y1 and x2 y2 will be given by this ratio. If you draw a triangle, right angle triangle, this distance is x2 minus x1 and this distance is y2 minus y1, right?
yeah,
So slope is basically the ratio y2 minus y1 by x2 minus x1. Okay.
yes,
So
sir.
how fast the line is increasing or rising up when you increase your x, right?
Yeah,
So for example, if x2 minus x1 was 4 and this went up by 2, then the slope m is half. When you increase the x values by 4, if the y values went up by 2, the slope is half, right?
yeah,
And this is, by the way, if you look at this right angle triangle here, this angle theta, tan theta is equal to y2 minus y1 by x2 minus x1, right?
yes, sir.
So slope of a line is also tan theta, where theta is the angle that the line makes with the x-axis, with the horizontal. So anytime you see a line, you can say that it makes this angle with the horizontal, let's say 30 degree, right?
Yeah,
So then slope will be tan 30. Tan 30 is equal to 1 by root 3 will be the slope of this line, which means that any 2 points that you take, y2 minus y1 by x2 minus x1 will be equal to 1 by root 3. Correct?
Yes, sir.
Are you understanding what I'm saying?
Yes, sir. I read HCM. The same things are written.
Okay, fine. So slope is an important concept because it tells us how fast a line is rising up, right?
Yes, sir.
Now, the point is that if I have a curve, not a line, what is the difference between a curve versus line? The difference
Uh,
is that line has a constant slope, right? And
yeah.
in a curve, the slope is changing. For example, you can see the graph of any line. Between any 2 points, the slope is same, right?
Yeah.
Because always the angle that it makes is same angle with the horizontal, right?
Yes, sir.
If the angle starts changing, then it will not be a line. It will start becoming a curve, right?
Yeah.
If you see this graph right now, the slope at every point is different, right?
Yeah.
For example, the graph is not rising up very fast here, but it is rising up faster and then faster here, right?
Yes, sir.
So the difference between a curve and a line is that the slope is changing. And why do we need to understand the slope of a curve and all? The reason is because that tells us how fast the curve is changing, how fast the curve is rising or falling, right?
Yeah.
Slope sort of gives us an indication of how fast the line is rising. For example, if I draw a line like this, you will notice that x doesn't change, but y keeps increasing, right?
Yeah.
So this y2 minus y1 by x2 minus x1 here would be something, let's say some constant by 0. X doesn't even change. So this is like infinite. Here the slope is infinite because the line is vertical. So your x doesn't even change and y keeps increasing, right?
Yeah.
On the other hand, if the line was horizontal, then x keeps changing, but y doesn't change, right?
Slope zero.
In that case, slope is 0, right? So that means the output is not changing even if you keep changing the x, right?
Yeah.
And here the output is changing so much even if you are not changing the x. So basically, you should sort of understand that the slope tells us how fast the curve is increasing or decreasing, right?
Yes, sir.
That is an important concept in calculus, and that is why we are talking about slope right now. So now, if we think about it, let's analyze a curve. Let's analyze a curve like this, and we will think about 2 points on the curve. Okay. So
Okay.
this point is, let's say the curve is y is equal to f of x. This point will be x1. So the output will be x1 comma f of x1, right?
Yeah.
And this point is x2 comma f of x2, right?
Yes, sir.
So now what we have to understand here, our question is how fast is the curve increasing? Is the curve changing or rising in the region between x1 and x2? In the region where x goes from x1 to x2, right?
Yeah.
That is what we want to understand. How fast is the graph increasing in this region? Why are we specifying the region?
Because we need to find the rate of change in that region only.
Because the rate of change can itself keep changing, right?
Yeah.
For example, if you take a equally big region here, it is not, the graph is not changing much, no, here. See?
Yeah.
But if you take an equally big region here, it is changing by so much here. So the rate of change of the function keeps changing. That's why we have to specify where we are taking it, right?
Yeah.
Are you understanding what I'm saying?
Yes, sir.
Okay, so if I want to find out how fast the curve is rising in this particular region, what we can find out is average rate of change. average rate of change of y is equal to fx in this region, right?
Yeah.
If you want to find out average rate of change, you can just join the 2 points like this with a line segment, and we can find the slope of this line segment. So slope of this line segment will tell us how fast it is rising roughly in this region, because this height will be y2 minus y1 or f of x2 minus f of x1, right?
Yes,
And
sir.
this difference would be x2 minus x1, right?
Yeah.
So if you connect the 2 points on the curve with a chord, this line will be called a chord, right?
Yeah.
Or it could be called, it can also be called a secant line because it cuts 2 points on the curve, right? So
Yeah.
if you connect it with a line segment or a chord, the rate of change is the slope of that chord, which is f of x2 minus f of x1 by x2 minus x1, right?
Yeah.
This tells us how fast the graph is changing in this particular region, and it is an average rate of change, right?
Yeah.
It doesn't tell us how fast the graph is changing at exactly one point. It tells us over a period of x1 to x2, right?
Yeah.
Are you understanding?
Yes, sir.
This is like saying, suppose you went from here to Chennai and it took, okay, you are in, not in Bangalore, right? You are where? Where are you?
I'm in Delhi.
So if suppose you went from Delhi to Gurgaon in 3 hours, right?
Yeah.
Then you would calculate an average speed for your journey, right?
Yeah.
That will be the total distance by total time, correct?
Yeah.
So this is like an average rate of change of the function, which is basically saying total change in y by total change in x, right?
Yeah.
But if you went from Delhi to Gurgaon at an average speed of 40 kilometer per hour, then do you think at every moment in that journey you went at 40 kilometer per hour?
No, it would vary.
Right. So it will vary depending on the traffic and depending on your speed and all, right?
Yeah.
So if somebody asks you what is the actual speed that you had at a particular moment, then obviously then 40 kilometer per hour is not the right answer. No?
Yes, sir.
So what we need to find out is the actual rate of change of a function at a particular moment, not over a period of x changing, right?
Yeah.
So far what we have found is average rate of change, right?
Yeah.
But what we need is an instantaneous rate of change. Okay.
Okay.
Do you understand what we are trying to get?
Yeah, the rate of change at x1.
At any point, x1 or any point in the middle, anywhere. But we need it at that moment, not over a period of time, right?
Yeah.
If we are able to calculate this, then we can define we will call that the derivative of f at that moment. Derivative of f, or we'll say f dash, or we'll say df by dx. Many ways to say the same thing. Okay.
Yeah.
So that concept is called the derivative. Derivative is basically telling us the instantaneous rate of change of a function at a particular point, right?
Yes, sir.
So far in 10th grade, you have no way to calculate that. Every time so far, whatever you have learned in physics and all, you have always calculated average speeds, average
Yeah.
speed or average rate of change. Never have you calculated instantaneous rate of change. Okay? Because that is a concept that comes with calculus. Is it clear what we are doing?
Yes, sir.
Okay. So now our job is to figure out how to do this instantaneous rate of change. So one way to do it, and the only way to do it actually, is bring the 2 points x1 and x2 close to each other. Okay. So
Okay.
if you try and bring the 2 points close to each other, let's say we keep x1 fixed and start bringing x2 closer and closer, right?
Yeah.
x2 was earlier far away, but we are bringing it closer. So think about it. As it becomes closer and closer, the line becomes like this, right? The chord earlier was like this, now it is becoming like this, right?
Yeah, it becomes collinear to the graph.
It becomes almost like the tangent at this point, right?
Yeah,
If you think about it closely, if the point is super close to it, right? Then it will almost start looking like the tangent at point x1, right?
yeah,
Tangent at x1. Actually, it is not the tangent because it is connecting x1 to x2, right? But what we are saying is bring x2 very close to x1, right?
yeah,
If you bring x2 very close to x1, the thing that you are actually doing is you are making your interval really small, right?
yeah,
If you're making your interval really small, then the average speed that you get or average change that you get, delta y by delta x, is going to be very close to the actual change rate, right?
yeah,
This is like saying, suppose you were on a journey from Delhi to Gurgaon, 9 a.m. to 11 a.m. It took you 2 hours to go. And suppose the distance was 50 kilometers, right? And
yeah,
somebody asked you the speed at 10 a.m., your speed at 10 a.m., right?
yeah,
Now, your average speed over the 2 hours, average speed over 2 hours was 40 kilometer per hour, right? Let's say.
yeah.
But speed at 10 a.m. will not necessarily be this average, right?
Yes, it will be different.
It could be anything, right? So
Yeah,
the way to calculate this could be if you kept a track of 9:59 a.m., what was the distance you have covered? And 10:01 a.m., how much distance you have covered? Then you can check the distance covered in the 2 minutes, right?
yeah,
So this is also an average speed, by the way, right? This is average speed of distance covered in 2 minutes, right?
yeah.
But do you think that this average speed is better or this average speed is better?
The latter.
This one is, no, this one is better, no, the former.
Yeah, yeah, the former.
This one is better because this one is more close to the 10 a.m. speed, right?
Yes, sir.
Now suppose actually technically it is still not instantaneous speed, no, it is an average over 2 minutes, right?
Yeah,
Now you do more. You say 9:59, 45 seconds to 10:00, 15 seconds. Now it's over this 30-second interval, right?
yes, sir.
If you calculate the distance traveled here and divide it by 30 seconds, then you would get an average speed, but that will be much more accurate, right?
Yeah,
Do you understand the process?
yes, sir.
So the more small you make your interval, the more small time you take the average, the better it will be at telling you the exact speed, right?
Yeah,
Basically, that is what we are doing in this graph also. Instead of taking a big average rate of change, we are trying to make the x1 minus x2 difference really small, right?
yeah,
And you will take the difference when x2 is close to x1. If you take the slope of that segment, then that will be the rate of change almost at x1, right?
yeah.
I hope you are understanding the idea.
Yes, sir.
Okay. So what is the mathematical way to do this? The mathematical way to do this is to say that suppose I have a point x comma f of x here, right?
Yeah,
I take another point which is close by, which is at x plus h comma f of x plus h, right?
yeah.
And I take another point before it, which is at x minus h comma f of x minus h. Okay.
Okay.
There are 3 points. This is one point, this is one point, this is one point, right? And we join A to B and also C to A, right?
Yeah,
Correct. And we are going to calculate average rate of change of the function between A to B. So basically slope of A to B. That would be what? Y2 minus Y1 by X2 minus X1, right?
yes.
So it will be f of x plus h minus f of x by x plus h minus x. So that becomes f of x plus h minus f of x by h, right?
Yes, sir.
And on the other side, from the left-hand side also, if you take slope of c to a, that would be f of x minus f of x minus h by x minus h, right?
Yeah.
So this becomes f of x minus f of x minus h divided by h, right?
Yes, sir.
And now this is still an average rate of change. It is not exact rate of change because it is average over this interval or this interval, right?
Yeah.
In order to make it exact, what we will say is we'll apply a limit to both things. Limit h tends to 0, calculate the slope of MAB. So basically that is limit h tends to 0, f of x plus h minus f of x by h. Do you understand that when you do limit x tends to 0, it will tend toward b tends towards a then?
Yeah.
B will become really close to a then, right?
Yes, sir.
Similarly, you also do limit h tends to 0 on m of a to c. So that will become limit h tends to 0, f of x minus f of x minus h by h, right?
Yeah.
Now this limit is the right-hand derivative. Right-hand derivative, and this limit is the left-hand derivative. Just like you saw earlier, right-hand limit and left-hand limit, right? We saw in the
Sir, but
Mhm.
if h tends to 0 in the equation for slope of AB, then
Hmm.
wouldn't slope of AB become 0?
H tends to 0, it will not become 0, no? See, it will become 0 by 0, right?
Yeah, that's basically 0.
No, that is not 0. We will see. That's because you have not done any limit questions. That's why you are getting this confusion. We will see some examples, so it will become clear, okay? So don't worry about it right now. Just understand what we are doing. Do you understand what we are doing?
Yes, sir, I understood that.
Basically, we are taking the slope and we are making h close to 0 so that a point comes close to a, right?
Yeah.
Similarly, on the other side also, we are making h close to 0. So then c will approach a from the other side, right?
Yeah.
Both the times we are taking limit of the slope, right?
Yeah.
If we had just written the slope was what? Average rate of change, right?
Yes.
So if you take limit of h tends to 0 on the slope, then that average becomes an instantaneous rate of change, right?
Yes.
For now, don't worry about how we'll calculate it. We'll do some examples, but you need to get this concept clear, what we are doing. Okay.
Yes, sir.
And this quantity is called right hand derivative, and this quantity is called left hand derivative, these two limits, right?
Yeah.
And if right hand derivative is equal to left hand derivative, then we say that derivative exists at that point. Derivative of the function exists. And we can find an instantaneous rate of change at that point. Only if both sides the slopes start matching. Do you understand? So,
Uh, Sir, but right hand derivative should be
hmm,
equal. So in the last class you wrote like limit x tends to a, then f of a is L, which was
hmm,
right hand limit. And in this case the function is in h. So right hand derivative is equals to right hand limit.
no. See, right hand limit was just the value of the function, no? Right hand limit and left hand limit, right? So
Yeah.
that was just saying limit of x tends to a f of x, right? That was L. This happens only when both sides the function approaches the same value, right?
Yes.
That is the concept of limit. Limit exists if both sides the tendency of the function is the same, right? On the
Yeah.
other hand, right now we are taking limit, but not of the function only, right? We are taking a ratio, right? We are not taking limit of the function. We are taking limit of the slope, no?
Yes, I got it.
So this is a slightly different concept, right? It uses the idea of limit, but it is actually calculating limit of the slopes, right?
Yes, sir.
What we are saying is if both sides, the limit of the slope should be matching, okay?
Yeah.
Then only the derivative exists. Okay, right now it may seem weird and all. We'll do some examples and you'll understand. So let's take some examples and find the derivative of some functions. Okay, so first example is y is equal to x square, right? The question
Yeah.
is find its derivative at x is equal to 2. Okay, basically another way to say this is find the rate of change of the function, rate of change of y is equal to x square function at x is equal to 2, right?
Yes, sir.
This is an instantaneous rate of change. I hope you are understanding the question.
Yes, sir.
So now let's see what we will do. So first we will draw a rough graph of the function. Let's say this is the graph. This is my point 2. And I will take 2 points, 1 point slightly ahead, just like we did earlier, right? And 1 point slightly behind, right?
Yeah.
And this point is A, this point is B, and this point is C, right?
Yes, sir.
So the point's coordinates are actually A is 2 comma f of 2, right? F of 2 is 4, right?
Yeah.
Because the function is y is equal to x square, right?
Yes, sir.
B is 2 plus h comma 2 plus h whole square, right?
Yeah.
And C is 2 minus h comma 2 minus h whole square, right?
Yes, sir.
So the process of taking a derivative is finding the slope of AB and finding the slope of AC and taking limit h tends to 0 on both the slopes, right?
Yeah.
So let's find slope of AB first. Slope of AB would be y2 minus y1 by x2 minus x1, right?
Yeah.
So y2 for AB is this, y1 is this, right? So it will be 2 plus h whole square minus 4 by x2 minus x1, which will be 2 plus h minus 2, right?
Yes, sir.
So this will be 2 plus h whole square minus 4 divided by h, right?
Yeah.
And what is slope of AC? Let's find that also. So that will be 4 minus 2 minus h whole square divided by 2 minus 2 minus h. So that is h, right?
Yes, sir.
So right hand derivative, according to our understanding, right hand derivative is limit h tends to 0, slope of AB, right?
Yeah.
Let's calculate that. So limit h tends to 0, what happens to this quantity, right?
Yeah.
2 plus h whole square minus 4 divided by h, right?
Yes, sir.
So calculate it, square it out, you will get 4 plus h square plus 4h, right?
Yeah.
Minus 4 divided by h. Limit of h tends to 0, right? So
Yes.
4 gets cancelled, right?
Yes,
And
sir.
notice what you're getting, h square plus 4h divided by h, right?
Yeah.
Can you directly put the value of h here? No, you can't because you have divide by 0. Can you
Oh.
directly put the value h here? Does it make sense? It doesn't. Because you cannot divide anything by 0, right?
Yeah.
What can you do, however? Can you cancel an h?
Yeah, by taking it common.
Take in common, cancel one h. You will realize that it will be limit h tends to 0, h plus 4,
Yeah.
right? So what is the limit of h tends to 0, h plus 4?
4.
So that is the right hand derivative. Do you
Okay.
understand?
Yes, sir.
Now let's check whether the right hand derivative and the left hand derivative is matching or not. So for left hand derivative, we'll have to take the slope of AC and put limit there, right?
Yeah.
So AC, that would be this one. So calculate it, 4 minus h square plus 4h, right? By h. Do you
Yeah.
understand this step?
Yes, sir.
This cancels, and notice here it is 4h minus h square by h. Again, directly you cannot put 0 because it will be 0 by 0, right?
Yeah.
But you can cancel an h, right? So you'll get 4 minus h left, right?
Yes, sir.
And what is the limit h tends to 0 on 4 minus h?
4.
It's 4. So both sides are matching.
Yes, sir.
Both sides are matching. So then you can say that the derivative exists, and the derivative is basically the slope of tangent to the function at a, or at x is equal to 2. And the derivative is 4. Okay.
Okay, sir.
The way to write it is f dash of 2 is equal to 4. Basically, f dash x is the derivative function, and the value of the derivative at 2 was 4, right, for us.
Yeah.
Or you can say dy by dx at x is equal to 2 is equal to 4, right? Now,
Yes, sir.
according to the rules that you have learned, y is equal to x square, you might have seen someone must have told you that dy by dx is 2x, right?
Yeah.
You might have learned this rule, no, in some coaching or whatever.
Yes, sir.
So if you follow that now, and on this, if you put in dy by dx at x is equal to 2, what is coming? 4.
4.
So the rule that you have learned, no, you must have learned this rule, x power n, then derivative is equal to n x power n minus 1, right?
Yeah.
This rule is supposed to be like a memorization thing for you. They have asked you to mug it up. But the real reason for this is the real meaning of this is this limit. Limit h tends to 0, f of x plus h minus f of x by h. That is equal to dy by dx. Right now we have written it as the RHD, by the way, right?
Yeah.
We could also have written it as the LHD because both have to be equal, right?
Yes, sir.
So this limit could be written like this also, f of x minus f of x minus h by h. Do you understand?
Yes, sir.
We have just showed you that for y is equal to x square, it came out correctly, no? Our limit method gave us the same answer 4, right?
Yeah.
We can prove many formulas now. For example, if you have x cube, right? Suppose we want to prove that the derivative of this is 3x square, right?
Yeah.
This is what you have learned from your formula, right?
Yes, sir.
So we'll do it by the limit method now. We will say it is limit of h tends to 0, f of x plus h minus f of x by h. This is the RHD, right?
Yeah.
So this will be equal to limit of h tends to 0. What is f of x plus h if my function is cube? It will be x plus h whole cube, right?
Yeah.
Minus what is f of x? It is x cube.
Yes, sir.
Correct? So now calculate it, expand it out. You will get x cube plus h cube plus 3x square h plus 3xh square minus x cube by h, right?
Yeah.
X cube gets cancelled, and notice that all the terms have an h, right?
Yes, sir.
So that h can get cancelled with the denominator, right?
Yeah.
You'll get h square plus 3x square plus 3xh, right?
Yeah.
And what is the limit as h tends to 0 here?
3x square.
So this is the way the formula has come. Okay. So
Yes.
this limit method is the real way to find the derivative. If you don't know the derivative of anything, the best way is to find it by this. Okay. Why are we
Okay.
learning the formula then? Because the formulas give us a shortcut to find derivatives. Because the limit method might be long, so we are avoiding all that work and trying to do a shortcut. Okay.
Okay.
So it's just a shortcut so that our derivatives can be quickly calculated. That's why we are learning the formulas. But the real logic and the real meaning of a derivative is what we have learned today. Okay.
Yes.
And it has a geometric meaning. The geometric meaning is that if you take 2 points, the slope of this was the average rate of change of the function. But if you bring the point close to it, then the slope becomes the tangent slope. And that is the derivative, slope of tangent. Right?
Yeah.
So the rate of the change of function at a particular point is equal to the slope of the tangent to the graph of the function at that particular point. Right?
Yes, sir.
Now, I have told you the real meaning of derivative, but that doesn't mean we can avoid learning the basic formulas. We can't avoid it because right now you have not done so much maths. The limits might be difficult for you to calculate, right? So
Yeah.
what you need to do now is HCV, there is a table of derivatives, right?
Yes, sir. There is one.
There is a table of derivatives and there are some rules for differentiation like product rule, differentiation of a constant, quotient rule, chain rule, and so on, right?
Yeah.
What you need to do is read that section. And if you are finding it a little difficult, or actually you need to go to NCERT 11th grade book. This will be available freely online. You can download it, right?
Yeah.
NCERT 11th grade maths book has a chapter on derivatives. It also has a chapter on limits. Why am I telling you this? Because you can practice some problems from there, right? There will be some
Okay.
examples, some questions there. You need to practice all of the derivative rules and how to take derivatives. You need to practice enough so that you become comfortable with it. Okay.
Okay.
The best place to practice would be this derivatives chapter and limits chapter from NCERT. Okay. So
Okay.
you need to do it, start doing it today only. Otherwise, you'll forget everything we did. Don't forget
Yes.
it because I will not be repeating this concept. Okay. So
Okay.
next class will be about practicing calculating derivatives and all. We'll do all of these rules, calculating derivative. That is what we'll do in the next class. And after that, next class will be about integration. So you have one class. The Monday's class will be about derivatives. Okay. And
Okay.
over the next 2 days, make sure you do enough so that you can ask me if there is a problem.
Okay.
Do enough so that you can ask me what your doubts are. Okay.
Yes,
And
sir.
by Monday's class, we'll finish derivatives. And on Wednesday's class, we'll be doing integration. Okay.
Okay.
So work on it and we'll continue. By next week, we'll be finishing the calculus that is required. After that, we'll be doing physics. Okay.
I have a few doubts in vector
Hmm.
theory.
What are the doubts?
So in HCV, it's the description for dot product of two vectors in terms of components.
Hmm.
They haven't taken cos theta. They have just multiplied the components.
That is the correct way to do it. The
But sir,
basic
why
question.
wouldn't we take the cos theta?
Do you know always the angle between two vectors?
No.
This is a very useless definition. I mean, it is the correct definition, but it's highly useless in real situations. For example, if I have a vector like this and I have a vector like this, they will give you the vector. They will never tell you the angle.
Okay.
Suppose I give you a vector, which is I plus 3j, and b vector, which is 5j minus 2i. Do you think someone will now tell you the angle also between them? Nobody will tell you that. So then
Okay.
can you use this then?
No, sir.
You can't use it. So the best way is to do dot product by components the way HCV has taught you. I plus 3j dot product with minus 2i plus 5j. Components which you do product, normal product like algebra, you'll do minus 2 I dot I, then 5 I dot j minus 6 j dot I plus 15 j dot j. But I dot I is 1 by definition. Why? Because the angle between I and I is 0.
Yeah.
So here the definition is useful because that tells us that I dot I will be 1, right?
Yes, sir.
Because the length of I vector is 1. So 1 into cos 0, right?
Yeah.
So here you get minus 2. It also tells us I dot j is 0 because the angle between I and j is 90. right?
Yes, sir.
So cos 90 is 0. So this term is vanishing. This term is also vanishing because j dot I is 0. And this term is plus 15. So the dot product is 13.
Right.
So it is very easy to find the answer by doing component method the way he has told you to. The reason it is not used so much this method is because nobody will give you the angle. Right?
Okay, sir.
They will give you vectors. They will ask you to do dot product, but they will not tell you, okay, this was the angle, please find it.
Yes, sir.
So read up on it. See, dot product is pretty easy. Cross product is a little more, you have to think about it a little more. We will discuss it. We'll discuss that in a separate class if when it is required. So you don't need to worry, but make sure that you work on the derivatives part. That's the important thing. Okay.
Okay, sir.
Download your 11th grade NCERT maths book. Do the examples from there. Do the theory from there. All of the stuff that is needed to understand it, we have already discussed today. So if
Yes,
you
sir.
start doing it today only, then you will totally understand everything. Okay.
Okay, sir.
Fine. We'll continue on Monday with derivatives and then we'll move on after that.
Okay, sir.
Fine. Bye.
Bye, sir.